Bismillahirrahmanirrahim. Dear students, yesterday we were talking about Spectral Series. So yesterday I completed the Lemon series. I'm talking about first year class, grade 11, and the topic is hydrogen spectrum. So in the hydrogen spectrum, we will discuss about the Spectral Series. And first we completed Lemon series. Now I'm going to start the Bomber series. Hydrogen spectrum. Hydrogen spectrum. So number 2 is Bomber series. Bomber series. Now this Bomber series, the first line and 1 must be equal to 2. And 1 must be equal to 2. If you see the diagram, or open the hydrogen spectrum for grade 11 book. So number and 2 will be equal to 3, 4, 5, 6 and 7 and so forth. So this is the first line of the Bomber series, second line, third line, fourth line and fifth line of the Bomber series. And I wrote yesterday the formula of the wave number. Wave number is equal to rate by constant 1 over n1 square minus 1 over n2 square, where r is a rate by constant. You can calculate the wavelength. Wavelength is equal to 1 over wave number. So after calculation of wave number, you can calculate the wavelength also by using this formula. So if I am going to use a Bomber series, so n1 must be 2 for the Bomber series, and 1 must be 2, and n2 first line 3, 4, 5, 6. Calculate the wave number, put the value of r, which is a constant, and calculate the wave number, then you have to convert into wavelength. So this is the Bomber series, and this Bomber series is lies in the visible spectrum. Means you can see this spectrum. This is a visible spectrum for the Bomber series. Number 3rd. Number 3rd is Bastion series. This is present in infrared IR region. So this is the Bastion series which is present in the IR region, and for the value of n1 must be 3. n1 should be 3, and n2 4, 5, 6 and 7 and so forth. So this is the Bastion series. n1 must be 3. So n2, the first line is 4, 5, 6 and 7 and so forth. So you have to calculate by using the formula. So this is in the infrared Bastion. Then number 4 is a bracket series. Bracket series. So bracket series also in the infrared region, IR, and this n1 must be equal to 4. In the bracket series, n1 must be 4, and n2 5, 6 and 7. So this is the first line of bracket series, second line and third line. And starting n1 is equal to 4, so you can calculate by using the formula. So number 50 is a Bastion series. So this different series also present in infrared, and N1 is equal to 5 and N2 is equal to 6, 7 and so on and so forth. So this is also in the infrared medium, yes. So by using the formula, you will be able to calculate the wave number and also wave length. So these are the spectral series. Dear students, if you see, there is a spectrum of hydrogen atoms showing the electron transition to give a different series. So there is a nucleus, and after nucleus you are seeing there is a first orbit, n is equal to 1. Then second, n is equal to 2, 3, 4, 5 and 6. There are 6 orbits are given here. So if you see for the Lyman series, so Lyman series start N1 and then it will go to 2, 3, 4, 5, 6. The values are given. You can calculate the wave number as well as wavelength. The units are nanometers as well as angstrom. So here this unit is a nanometer. You can change into nanometers. Second case is for the bomber series, which is n is equal to 2 and then n2 is equal to 3, 4, 5, 6, 7 and like this one. So you can see this one I have written there. Explanation of hydrogen spectrum on the basis of Bohr theory. So the first spectral line were discovered in 1887 by Lehman and Balmer. In 1887, the first spectral line was observed or discovered by the Lehman and Balmer, and no satisfactory reason became available till 1913. Bohr in 1913 proposed atomic model, gave the following explanation. You done the Bohr's atomic model in the very beginning of this means topic, Bohr's atomic model. He said that when the current is passed through the hydrogen in a discharge tube, the condition you know when the discovery of electron at very low pressure and very high voltage. The gases are good conductor only when very low pressure is adjusted and high electric voltage is passed. So this hydrogen molecule is broken down. These atoms absorb energy from the electric spark when you are going to give the electric current. So the amount of energy is absorbed by these atoms. So the electrons of hydrogen atoms are excited, means they jump from lower energy to higher energy, then they are going to absorb the energy. The higher energy orbit to which the electron migrate depends upon the amount of energy absorbed by the electron. So this diagram I told you, which is given for all spectral lines, spectral series from Lyman to Coffin. So this is given same, I'm not going to repeat it. And 1 is equal to 1, this is called Lyman series, and 1 is equal to 2, this is called a Bomber series, and so forth. So by using the wave number formula, we done the derivation of wave number. That's Z is the atomic number, M is the mass of electron, E is the charge on electron, A is a constant, epsilon is a constant permittivity of vacuum, H is a constant, C the velocity of light. So if you are talking about the hydrogen, then Z is equal to 1. So for hydrogen, Z is equal to 1, which is a constant, and put all the constant terms, you will get the value of R. The value of R is called Rydberg's constant, which is 1.09687 into 10 to the power 7. This is called Rydberg's constant, which is given on the next page. We have to solve these numericals according to the formula given. All. So at least 2 examples must do in your copies. Means 2 for the lemon, 2 for the bubble, and 2 for others. You have to calculate in your copy. This is about the hydrogen spectrum. Now, dear students, the other topic I am going to start is called Planck's quantum theory. Planck's quantum theory of radiation. So, Max Planck, exactly 1900. Max Planck in 1900 presented theory that's called the Planck's quantum theory of radiation. This is about nature of the light. So according to his first point, which is very, very important here, when the energy, suppose electrons, energy is going to be absorbed or emitted. According to his theory, he said that the energy is not emitted or absorbed continuously. The energy must be absorbed or emitted in discontinuous manner. Quanta, Greek word means packets, small packets, bundles, bunches. Every bundle, every packet, every bunch has its own energy. Just like bunch of key contain 3 keys, second bunch contain 5 keys, then maybe 1 key, maybe 2 keys, different. So every quanta has its own energy. Either the amount of energy is evolved or absorbed. And this is in the form of wave packets, wave quanta. In the form of light, this quantum of energy we call photon. Photons we call. In case of light, the quantum energy is often called photons. This is the point number 1, which is a very important point for the Planck's quantum theory of radiation. The amount of energy associated with the quantum of radiation is directly proportional to the frequency. Energy is directly proportional to the frequency. Like this one. This is a frequency. Energy is directly proportional to the frequency. If I remove this proportionality sign, then you have to put a constant. That's why energy will be is equal to h and frequency, where h is a Planck's constant. H is a Planck constant and its value is h is equal to 6.626 into 10 to the power minus 34 joules second. H is the Planck's constant, so the value is a fixed 6.626 10 to the power minus 34 joules second. So when you put the value, if you know the frequency, you will be able to calculate the energy or total energy of the electron. Dear students, frequency is inversely proportional to the wavelength. Frequency is inversely proportional to the wavelength. It means that frequency will be equal to constant c over lambda, wavelength. Where c is the velocity of light, so the value of c is 3 into 10 raised to power 8 meters per second. C is a velocity of light. The velocity of light value is 3 into 10 raised to power 8 meters per second. So if you put the value here and if you have the wavelength, you will be able to calculate the frequency. So if you put this value in this equation, so the energy will be is equal to H Planck's constant, V is equal to C over wavelength, like this one. So you will get this formula where capital E is the energy, H is the Planck's constant, C is the velocity of light, and this is a wavelength. So this is the one thing. Second thing is that wave number is also inversely proportional to the wavelength, 1 over wavelength. Wave number is also 1 over the wavelength, like this one, this formula. 1 over wavelength. So it means that if you put the value, so you will get E is equal to H C by this one. You will get this formula if you see your book. E is energy, H is the Planck constant, C is the velocity of light, this is the wave number. Now students, you must know the definition of all these. So if we are going to conclusion that energy of photon is related to frequency, wavelength and wave number. So the number of waves passing through a point per second is called frequency. The distance between two adjacent crest and trough called wavelength. It is expressed maybe in the nanometers or in angstrom. You can represent into nanometers and you can represent in the angstrom. So there is a one numerical. So you are supposed to take out your calculator. I am going to solve this. Take out the book and your calculator must. So students, example number 2 point in my book 7, a photon of light with energy. In my book, this is the example number 2.7. So energy is given. Energy of photon is given, that is 1 into 10 raised to power minus 19 joules. This energy is given. Emitted by the source of light. Number A question. Convert this light in the wavelength. Wave number. Frequency. 3. You have to calculate these 3. Wavelength, wave number and frequency. The units are frequency is in the cycles per second, we call hertz, and in the wavelength you have to convert per meter and also meters respectively. So we have to calculate one by one. We know that E energy is equal to H mu, H E frequency. So this is the formula of energy. So energy is given. If I want to calculate the frequency, the frequency will be is equal to energy over Planck's constant. So put the value. Energy is 1 into 10 raised power minus 19 joules. And Planck's constant is 6.626 into 10 raised power minus 34 joules second. So if you have a calculator, my calculator is here, you have to also use your own calculator. So 1 divided by 6.626. The answer is 0.1509. Now students, down minus 34 and minus 19. So this down minus will be plus. So 34 minus 19, you will get plus 15. And joules and cancel, so you will get per second. This is your answer. Or if you are going to move the decimal here, so this is a 0.1, now you are making 1.5 increase, it should be decrease, so that is why frequency will be equal to 1.509 into 10 raised power plus 14 per second. So this is the answer of frequency. This is a frequency. Now students, you have to calculate the wavelength. You must use these formulas. I am going to omit. Now wavelength, this. The formula is given. Frequency is equal to velocity of light over wavelength. So wavelength will be equal to C over frequency. C over frequency. So now wavelength, C is a velocity of light, 3 into 10 raised power 8 meters per second, divided by frequency. Just we calculate 1.509 is 1 into 10 raised power plus 14 per second. So now students, if you calculate this, you should have your calculator on 3 divided by 1.51. So the answer comes is equal to 1.9867 into 10 raised power. This is a plus 14, now it become a minus. So 14 minus 8. You will get minus 6. And seconds cancel, you have meters. This is the answer of wavelength. Wave number is equal to 1 over wavelength. Wave number is equal to 1 over wavelength, so put the value 1 over wavelength is 1.9867 into 10 raised power minus 6 meters. So students, divide by 1. So 1 divided by 1.986, you got 0.503 into 10 raised power minus 10 into plus meter changes into per meter. Now if you shift the value point, so wave number will be is equal to 5.03 into 10 raised power plus 5 per meter. This is the wave number. So all formulas you should remember. When you know the formula, you will be able to calculate the frequency, wavelength and wave number. Now it has a part B also. By using same formulas, but units are different. In different units. If you read the part B, convert the energy of photon into erg and calculate the wavelength in centimeters, frequency same in hertz and wave number in per meters. So students, we have conversion. Now how we are going to convert this? One joule is equal to 1 into 10 raised power plus 7 erg. 1 joule. So dear students, you have an energy that is 1 into 10 raised power 1 into 10 raised power minus 19 joules. So when you change into erg means you have to multiply 1 into 10 raised power plus 7. So your answer will be minus 19 and plus 7. You will get 1 into 10 raised power minus 12 erg. So now you have to use this value instead of this energy. This is for the energy. Okay. H, Planck's constant. The Planck constant value is 6.626 into 10 raised power minus 34 joules second. Don't make mistake. Don't write erg. Some students they consider erg second. That's why I only write ERG. And this is the joule second. So when you convert into erg, so it means 1 into 10 raised power plus 7. So your answer will be 6.626 into 10 raised power minus 27 erg second. This is the erg second. So now use the same formula and calculate. Same formula means frequency is equal to E over H. I have written all these things. Just put the values as same and calculate yourself at your home. Frequency is equal to E over H. E is given, H is given and wavelength is equal to c over velocity of light, and frequency velocity of light 3 into 10 raised to power 8 meters per second. But when you change into centimeters, centimeters are smaller quantity and meters large quantity, so this will be in the 10 raised to power 10. So 3 into 10 raised to power 10 centimeters per second, and frequency is given 1.15 10 raised to power minus 14 plus 14 per second. So you will be able to calculate the all, means you will be able to calculate the frequency, wavelength, wave number by using the same formulas in hertz already I have converted. So this is the example. You have to calculate the one portion only. Now students, second other topic. Now, X-rays. X-rays. Students, X-rays is still unknown, no name, just like X, Y, Z. These X-rays were discovered accidentally. Wilhelm Röntgen in 1895 accidentally discovered X-rays. If same experiment, if you see discovery of electron, if cathode rays are pointed to fall on a heavy metal target, there are produced some penetrating short wavelength rays are called X-rays. You can see the diagram from the cathode. Cathode rays are traveling in a very straight manner, and they are going to target at a heavy metal anode. So then the short wavelength unknown type of rays are formed. These are called X-rays, accidentally. The X-rays are electromagnetic radiation of very high frequency, depending upon the anode target, means what kind of element metal you use. It depends upon, we will discuss the discovery of atomic number by using this same method. So students, the frequency of the X-rays depend upon the atomic number of the metal. So frequency is directly proportional to the atomic number and inversely proportional to the wavelength. Depending upon the nature of the anode, so oftenly we use tungsten filament for this purpose. So X-rays are emitted from the target in all directions. The small portion of them is used for the useful purpose. We have to use it also. X-ray, you know. The wavelength of X-ray depends upon the nature of target. I told you, wavelength is inversely proportional to the atomic number of metal, and frequencies are directly proportional to the atomic number of the element. So students, just I told you here the discovery of X-rays by Wilhelm Röntgen in 1895. Accidentally he discovered X-ray by using the same experiment which was done by the Crookes Faraday for discovery of electron. The difference is here, he used different kinds of anode. Different kind of anodes were used, metals were used, so wavelength and frequency of the X-rays depend upon the nature of the anode. So we stop here after X-rays. Inshallah, next time we will discuss about the atomic number, continue this topic, X-rays.